Alright guys, so we are looking at 9.1c, lines of best fit. So we've talked about best fit lines a little bit, but we're really going to dive into it and go over exactly what it means. So remember, pause this video, rewind it, and there should be 2 or 3 parts to it, so make sure you're filling out your notes with it. And if you have any questions, let me know. So it says most real-world data does not fall perfectly on a line. This is like things like with the constant rate of change, something like that. However, if the data on a scatter plot resembles a line, we can fit a line in the data. So I want to write a function for the line and use this function to solve a problem that makes a prediction. So essentially what we're doing is we're going to have a bunch of lines, a bunch of points, and we're going to say, you know what, this makes a line, so draw a best fit line. That's a line that is pretty close where it hits most of the points. So like right here would be a best fit line. It's pretty close to all of them. And then I want you to give me the equation of this line. So the f of x equals whatever, or y equals whatever. That's what today is mostly about. So let's go ahead and says, the line that you use to represent the data is called the best fit line. That's that red line I just drew. We will refer to the function you write for the line of best fit as we predict as the prediction function. The most common way to find a best fit line is to draw a straight line through the center of the group of data points plotted on a scatter point, having points above and below the line. So, let's talk about association before we begin drawing this best fit. This isn't on your notes, I just want you guys to remember. Remember, a positive association is when the points are going in an upward position. A negative is when they're going in a downward position. Something that looks like this. And no association, when it's kind of random, we don't really know where the points are going. They're not really going up or down, it's just all over the place. So let's go ahead and look at this now. It says examine the scatter plot of the following, and it says state the association and explain. Well, this would be a positive and linear association. And then it says because the points are going in an upward position. Because the x and y, sorry, that's super messy. The x and y points are both going up. So because when x increases, y also goes up. And it says use a ruler to draw a line of draw a line of best fit through the data points that captures the general trend. So let me show you what not to do. What I don't want you to do is always start at the origin. That's not the case. And you don't want to say, okay, well, there's my best fit line. That actually would not be our best fit line. We want to start somewhere around here, and we want to go in an upward area. And I want you to notice you don't want to have it just above or just below. You want to hit it so you hit the majority of the points. So it's not hitting all the points, but it's a nice general form of it where you have some above it, you have some below it, but pretty much that's how the line follows. So that would be my best fit line. So on the next step, it says estimate your slope and y-intercept. So remember, we're estimating. We might not all have the same one, but for most part, they're going to be pretty similar. So right here is my y-intercept. This is my b value. That's going to be 1. And then if you see, we're going to find the slope by just going change in y over change in x. And we're really going to focus on the points. Now it's important to notice on scatter plots that they're not going up by the same amount on the x and y axis. For instance, this is going up by 2's on my x, so 2, 4, 6, 8, and going up by 1 on my y axis. So I want to figure out how far I went over to this point. So I went up 1 and over 4. Now remember, each one of these boxes counts as 2 on my x-axis. That's why I went over 2, 4. And if you see I go up by 1, I go over by 2. It's not perfect, but it's pretty darn close. That's my slope. So my m would be 1/4. So the equation that I am going to use for my best fit line would be y equals 1/4 x plus 1. This would be the equation of the blue line. This would be the equation of the best fit line. So, it says estimate the slope of your line. We actually just did 2 steps in one. I did C. So C, this is what I want you to write. And then, with my B value, which would be this, we would have enough to write the equation, which is y equals 1/4 x plus 1. It does say write it as a function, so just so you know, we'd want to write it as a f of x equals 1/4 x plus 1. So this is the final answer I'd want for D. So where it says, use your prediction to find the value of y when x is 12. So we're going to use our equation of y equals 1/4 x plus 1. And it says when x is 12, so it's going to be y equals 1/4 of 12 plus 1. And then my final answer would be y equals, not my final answer, it would be y equals 3 plus 1, because 1/4 of 12 is 3. When I add those together, I get 4. So what this is saying is when I plug in 12 to my answer, 12 in my x, I should get an answer of 4. So let's go on my x-axis. I'm going to go over to 12, and I'm going to see where it hits here. And my y value, my output, was 4. So this point right here is 12, 4. So that means my equation matches my best fit line. Sweet. So let's go and try the next one. It says use your prediction function. So we're going to write it as a function this time. So it's going to be 5.5. This is my y value. It's my output. And that's going to equal to 1/4 x plus 1. So I want to figure out what my y value, what my x value would be if I plugged in 5.5 for my y. So let's go ahead and solve that. First, I would minus 1 on both sides to have 4.5 equals 1/4 x. I'm going to turn this into a mixed number, so this would be 4 1/2, which is equivalent to 9/2. And that's going to equal 1/4x. I'm now going to multiply both sides by 4. This would reduce this to 2, which means I would get an answer of 18. Which means, let's see if this is correct. If I had a value of 5.5, which is about right here, I'm going to go over to this line, which would be about right here. About right there. So then when I go down, it would be about 18. And if you look at that, we're pretty darn close. We're right before that. So that's showing that my best fit line does match my prediction. So I am really, really close to it. So just as a reminder, with best fit lines, we're not always going to be perfect or exact, but we should be pretty darn close. So now let's go ahead. It says examine the scatter plot. Does it support the coordinates you found on E and F? And it did. They're both very close. So remember, if I made a best fit line and my equation did not come that great for a best fit line, I would probably want to recheck it. So it would be yes, because both answers were pretty close to the best fit line. Both answers were close to the best fit line. All right. So now what we're going to do is look at number 2. So this one's a little different. Same idea. We want to make a best fit line. So first off, let's examine the scatter plot and complete the following. So state the association. This is linear and negative association. Now use a ruler and we're going to draw a best fit line. Remember, we want to hit most of the points, and it would look something like this. So you can see some are above it, some are below it, but overall I'm hitting a large cluster. Remember, a bunch of points that are grouped together. I'm hitting a large cluster of points. So I want to estimate my slope. So first off, I already know my line's going down, so it's going to be a negative slope. And essentially, if I went down 1 over 2, it's pretty close. Down 1 over 2. So as you can see, if I'm going down 1 over 2, it's not exact, but it's pretty darn close. Now remember, each one of these values there's a gap of 2 between them. So each x value going across, each one box is 2 places on my x value. While going up and down, it's only 1 place value. So I know my slope, I just went down 1 and over 2. And I know it's negative because the slope is going downward. It also asks us to write a prediction, so write an equation for the prediction. You need your y-intercept, which is positive 8. I would say it's pretty darn close. So my function of x would equal to negative 1/2 x plus 8. This is the equation I'm going to use to predict all my answers. Alright, so it says use your prediction line to find the value of y when x is 1/2. So we're going to continue to use that equation, which was negative 1/2 x plus 8. And I'm going to plug in 1/2 in for x. So it's going to be negative 1/2 times 1/2 plus 8. And that's going to give me y equals negative 1/4 plus 8. And that would simplify to y equals 7 and 3/4. So let's go ahead and find this point. It was positive 1/2, comma 7 and 3/4. Let's see if that works. So I'm going to go over to a quarter, which is, if this is 1, this would be about 1/2. So I would go up right here, put my value right here. And you can see it's pretty darn close. If this is 7, this is 8, it's a little bit more than halfway. So 7 and 3/4 does work. Alright, so let's look at the next one. Let's say when y is 3.5. So I'm going to have 3.5 is equal to negative 1/2 x plus 8. So the first thing I would do is minus 8 on both sides to get negative 4.5 is equal to negative 1/2. I'm going to turn this into a improper fraction just so they're easy to multiply and divide. And I'm going to multiply both sides by negative 2. Which means when these cancel, I'm left with positive 9 is equal to x. So this is saying that the point would be positive 9, 3.5. So let's go to positive 9, which is right here. I'm going to go up, so it should be about right here. And that means my output, my y value, it's just below 3.5. So I would say that's a pretty good guesstimate when I plug that in. So it looks like my best fit line looks pretty good. So it said examine the scatter plot. Does it support the coordinates you found in part E and F? It says yes, it does. Sweet. That's good stuff. Okay, so what we're going to do is we're going to take a pause right here. Go ahead and open the second video, and you can begin to fill that out.